Hello again. Today we will work with a mixing problem. We are in a Garmont seed store. Its name is GM. GM Seeds is the part of Garmont dedicated to the sale of combinations of seeds to produce healthy breakfasts that assure their clients a balanced diet. For this purpose, GM has warehouses filled with different types of seeds that allow them to make the right mixtures. This is one of the warehouses. After they have selected the ingredients, then mix them to obtain different types of combinations. Each combination has certain restrictions on the amounts of ingredients to be used. Let me show you the characteristics of each type of mix for a branch of the different GEM products. GEM produces 3 types of blends: normal, special and extra. All mixtures are produced based on 4 different ingredients: almond, Brazil nuts, coconut, and pumpkin seeds. The differences between the mixtures lies in their percentage of each ingredient. This table summarizes the main characteristics of the mixtures. As you can see, normal mix requires at least 15% of each ingredient. The special blend requires a minimum of 20% of each ingredient, and a maximum of 40% of any of them. Finally, the extra mix has no restrictions on the amount of almond or Brazil nuts. But it should contain at least 20% of coconut, and a maximum of 20% of pumpkin seeds. An extra restriction of GEM is that each type of mixture must represent at least 25% of the total production. The selling price per pound of each of the products, the cost per pound, and the quantity in stock of each ingredient. They also appear in this table. There is a small, but significant difference between this type of problem and the previous one. In the previous example, the resources had a fixed use. When this happens, then we know the amount of raw material that we will need by simply defining the number of units we will manufacture for each product. But in this problem, if we define the number of pounds we are going to produce from each type of mixture, we do not know how much ingredient we will use in the mixtures. For example, if we produce 100 pounds of the normal blend, then we know that we should use between 15 and 55 pounds of almonds, but we do not know the exact amount. If the amount of raw material used in each mixture were fixed, then we would only need 3 variables. When the quantity of raw material in each mixture is not totally fixed, then we need to define the decision variables as the quantity of each ingredient used in each product. This means that, for this problem, we will have 12 variables. Again, I will reduce the size of this information in order to formulate the problem. We will start by defining the decision variables. Let x, I, j, be the amount of ingredient I in mixture j. In this way, if we mention the variable x, a, s, then we will be thinking about the amount of almond in the special blend. As always, the profit is defined as total income minus total cost. Total income is the sum of product sales. The total cost is the sum of the costs of the materials used. In this way, we can represent our profit as the following expression. The blue part represents our income. The red part represents our costs. Obviously, the complete expression represents our profit. And therefore, the expression represents our objective function. Because this is the function we want to maximize. On the other hand, this expression can be reduced by algebra. And then we can write our objective function as. Now, we must think about our constraints. We have different kinds of constraints. The availability of the raw material. The constraints of each type of mixture. Constraints on total production. Let's take a look at the data table. As you can see, we have 600 pounds of almond, 400 pounds of Brazil nut, 500 pounds of coconut, and 900 pounds of pumpkin seeds. Think about the almond constraint. The amount of almond in the normal mixture, plus the amount of almond in the special mixture, plus the amount of almond in the extra mixture, cannot exceed 600 pounds. In the same way, we can transfer this reasoning to the other ingredients. So, we will obtain the following constraints. Now, think about the constraints of ingredients in each mixture. The normal blend requires at least 15% of each ingredient. Let's start again thinking about the almond. The amount of almond in the normal mixture should be at least 15% of the total of the mixture. Again, through algebra, we can transform this expression. Transferring this reasoning again, we can obtain the constraints for each ingredient in the normal mix. We will have 4 constraints, 1 for each ingredient. Now, we will consider the constraints for the special blend. The special blend requires a minimum of 20% of each ingredient, and a maximum of 40% of any of them. Let's start with the almond. The amount of almond in the special mixture should be at least 20% of the total of the mixture. And the amount of almond in the special mixture should be, at most, 40% of the total of the mixture. We must express 2 constraints for these conditions. Again, we transform the constraints. Because each ingredient has the same conditions, then we will get 8 constraints for this part of the problem. In the extra mix, there are only 2 constraints. These constraints only exist for coconut and pumpkin seeds. I am sure you will not have problems getting to the following expressions. Finally, we must add constraints to indicate that each mix should mean, at least, 25% of the total output. For the normal blend, this constraint may be denoted as the following expression. Because each mix should represent at least 25% of the total production, then we will have 3 constraints. The overall formulation of the problem is as follows. To obtain the solution, we enter this problem into any linear programming software. These values represent the solution to the problem. And the profit will be $14,791.70. I hope this problem has been useful to you. I would just like to make a very important observation. If the quantities used in each mix were fixed, we would only need 3 variables. These 3 variables would be the amount of pounds of each type of mixture. Because the amounts of the ingredients are not fixed, then it was necessary to use 12 variables. When you formulate the problem, always consider this detail. Using the correct number of variables makes a problem easier to formulate. See you soon.